Okay, so if you turn to page 5 of your packet, they're actually not numbered on the bottom, but where page 5 would be, it's titled Solving Quadratics and Polynomials of Higher Degree Graphically. What we're going to do here is we're going to graphically determine the solutions to polynomial equations or polynomial functions. So if you take a look at number 1, it says, which set lists all the roots of f of x equals 0? Okay, so the roots, or another way of saying, way of saying roots would be zeros or solutions, they all mean the same thing, are the x values at which the function crosses or touches the x-axis. So if we take a look at number 1, we can see that there's actually 3 spots where the graph touches or crosses the x-axis. Right here at x equals -2, right here at x equals 0, and right here at x equals +3. So those would be our roots, or our solutions, or our zeros. They all mean the same thing. So here we go. And if you take a look at the answer choices next to number 1, you could see what they do is they use the curly brackets, and they just list them all out with parentheses in between each solution, or each root. So this is our answer, which is choice 4. Okay, so now if you turn the page and take a look at number 5, this time they don't give us a picture. They say, what are the zeros of the polynomial function, and they give us the equation. So what we're going to do is, if we're going to do this graphically, we're going to have to take out our calculator, and let's graph this. So let me just set up a set of axes here. And if you go to y equals in your calculator, and you graph this function, what we'll see is, let me just graph this out. I'm not even concerned about the y values. I'm really just looking at where the graph crosses the x-axis. So what we'll see is we have a function that crosses the x-axis at x equals -4, x equals -1, and at x equals 3. Okay, our function looks something like this. Okay, so our zeros would be x equals -4, x equals -1, and x equals 3. All right, now in part B, they want to know what are the factors of this function. Well, so the factors are going to have the opposite sign of your zeros here. So if x equals -4, that means we're going to have a factor of x plus 4. If x equals -1, that means we're going to have a factor of x plus 1. And again, if x equals +3, we're going to have a factor of x minus 3. So these right here are the factors of our function. If you were to, double distribute, combine your like terms, and then distribute this to the x minus 3 and combine your like terms again, you would wind up with this function right here. So these are our factors, and these are our zeros. Okay, and the last example we're going to do is number 10. So if you could flip to that, it gives us a picture, and it says, given that the leading coefficient is 2, write an equation for the function below in standard form. Okay, well, first thing we're going to have to do in order to write this equation is we're going to have to look at our zeros. So we see here that we have a 0 at x equals -2. I'm just going to write these out. We have a 0 at x equals 0. And we have another 0 right here at x equals +2. Now, if you recall from our last example, we can use these zeros to help us write the factors. And these factors will help us to write our equation. All right, so let's call our equation f of x. Okay, and remember, if we have a 0 at x equals -2, the factor that goes along with that would be x plus 2. So I'm going to set this equal. And our first factor is going to be x plus 2. Okay, if we have a 0 of x equals 0, you could write that factor as, if you want, x minus 0. But what is x minus 0? X minus 0 is just x. So I'm just going to call that x. Okay, and then if we have a factor of x equals +2, that'll give us a factor of x minus 2. Now, there could be a number in front of this function, right? It could be a 1, it could be a 5, it could be a -3, it could be a fraction, it could be anything. Now they tell us in the directions that the leading coefficient equals 2. So they're telling us right off the bat that there's a 2 as our leading coefficient. Okay, now, I mean, technically this right here is our function. This is an equation of this graph right here. But they tell us they want us to write it in standard form. So standard form means we need to take all this and multiply it out. So first thing I'm going to do is I'm going to rearrange this. I'm going to take this x right here and just bring it over with a 2. So it says 2x. So we have f of x equals 2x, and then I'm going to bring down my x plus 2, and I'm going to bring down my x minus 2. All right, so let's keep going. So I'm going to first multiply these out right here. So let me just bring the 2x down. Now, some of you may be looking at that and say, oh, look, this is dots, right? Wouldn't x squared minus 4 factor to x plus 2 and x minus 2? So if you were to multiply this out, you would get x squared minus 4. I mean, if you want to show the work, you would have x squared, and then a minus 2x and a plus 2x would cancel out with each other. And then positive 2 times negative 2 is negative 4. So this is going to leave us with x squared minus 4. Okay, and then finally to finish, just distribute your 2x in. So that would give us 2x cubed minus 8x. And this is in standard form because we have our terms going in order of the exponents are descending, right? We have our highest exponent first and then our lowest after that.